So, hi, Jackie. I guess it is pronounced correctly because
Yes,
in the pre-show we had a chance, to clarify that. And I ask you, we could write Java the same way with the C, right?
exactly. Yeah. So my name is written Ceki. It's the Turkish spelling of my name, and C in Turkish is pronounced J,
Mhm.
like Java. Exactly.
So I could write CAVA, right? Java.
Exactly. Yeah. I think even in no, I don't think in Turkey they write it this way, but they could, of
They
course.
could. So
Yes,
you are absolutely Java compatible. So
I'm
this were
Java compatible. Yes.
That's cool. So the most important question today, of course, is what was your first computer?
Of course. My first computer it still is. No, I'm joking. It was a PC XT with an 8088 processor.
Ah,
What, like piece of garbage, really.
I
Um,
had similar engine, 8080. I think it was 8080. It was also a very old one, but it was tiny. This was the interesting part. I remember, the display was tiny. Everything was tiny.
yeah, and but I remember most were the floppy disks. I
Hmm.
had the 360 kilobyte floppy disks, and I remember the pain installing Borland Pascal.
Yeah,
Like
2 disk. I remember.
I don't know if it, I remember that it was quite painful,
Hmm.
and for some reason it didn't work on that PC, so I had to buy an 286 machine, and it was very expensive, and I got a summer job to buy it, and so on. So yeah, it was quite a quite a thing to install Borland Pascal. And for some reason, a few years later, they stopped. They went bust or something. Borland.
Uh-huh.
So yeah, my whole until like a week ago, all my personal computers were Windows PCs. I never worked on Macintosh or Apple. Or actually, at school, I did for a very short while.
Hmm.
And last week, I got a Chromebook, and we're recording this on a Chromebook.
Oh, you are too fast. What I wanted to know is what you did with your first computer first. So you started to play game or do immediate action, to start to install Turbo Pascal.
I think wanted to learn MS DOS initially. I mean,
Why?
that's my memory.
You were a kid, I guess, right?
No, I was already 18. I mean,
Okay,
yeah,
okay.
comparatively a kid, but still, for
Yeah,
well,
we're
I
now
was at
20. We
university.
now 20. It doesn't matter, right? So I mean, 2 years back and forth.
So I was at university already
Okay.
for my first computer.
Mhm.
So
Okay,
it's
so
quite
then it
old.
makes sense. So you had to learn MS-DOS or Turbo Pascal, whatever. Exactly.
Um, you could say so because well, not exactly because I started doing physics at university,
Okay.
and computers were not a must have at the time.
Mhm.
Um, I remember the first course I had. We used the locally produced computer, which was called the Smacky, and it had a mouse. And the mouse was invented at the school as as well as the computer Smacky, and the mouse became Logitech mouse at the end, or a few months or a few years later.
No
The
kidding.
company Logitech is based on EPFL, the school I went to.
Where is
Uh,
this school?
it's in Lausanne,
Mhm.
in Switzerland,
Okay.
in this
Mhm.
French-speaking part.
Okay.
And I remember programming a game, a board game where you had to find like missing pieces or something like that.
Mhm.
And I had so much fun doing that. Uh, I redid it in Turbo Pascal during my spare time. I spent all my time playing on that or making that
Mhm.
game. So that's how my love affair with computers started.
But you are too fast because you always wanted to have computers. So because if you got a computer with 18 and you started with MS-DOS, you in my opinion, you had to be passionate, before that somehow as a kid. So you always, wanted to have computer, or why? I mean, because now you say you enjoyed really to, to create the game. It was like you were not aware that you like computers, and then you had the chance to get the computer, and then it just exploded, or what was the story behind?
Listen, it was a long time ago. It was 3 decades ago. So more than 3 decades ago. And I don't exactly remember. And I, I, I was curious about computers, but I didn't know much about them. And I was aware that everybody was excited about computers,
Mhm.
but I wasn't passionate about computers. And at what time, at an early stage, I remember saying to myself, these computers, they're really stupid. They suck. And I wanted to throw mine out of the window at one
Mhm.
point. I remember it was kind of and then, and then I said, oh, okay, I'll give it another shot. And that
Mhm.
was like 35 years ago.
Mhm.
So I don't really remember if I was passionate about computers or not. I was curious about them, and I liked programming. I think that's the main thing. I really enjoyed programming.
Mhm. So this is why you like the game, right?
Exactly. So it gave me something to do. It was kind of a difficult puzzle to solve, a big puzzle, and I really enjoyed it. So that's the main thing.
And you studied computer science or something different?
Physics. I started
Wow.
studying physics, and I remember um, spending more and more time programming than studying. And fortunately, I kind of had a lot of baggage, a lot of uh, things to build upon in the first year, and I passed by like it was kind of okay, and then the second year I had a harder time. I had bad grades and really good grades, so it kind of compensated. And then I had the opportunity to switch to network engineering,
Mhm.
telecommunications and network engineering in my third year,
Mhm.
and I think it was a good choice.
Yeah, and you enjoyed it better or more, the network
Yes,
engineer?
yes,
Mhm.
absolutely. Because there was courses about cryptography, which I really liked. We had a really good teacher, I must admit.
Mhm.
Um, I can mention his name. His name was Tyrant, Tyran in
Uh-huh.
French.
Mhm.
Very funny name. One of the best teachers I had at EPFL. Um, cryptography, we had courses on uh, queuing theory,
Mhm.
signal processing. Really, courses that I quite enjoyed. I must
Mhm.
say.
Okay. So it's almost like computer science. I did
It
similar things, I remember.
it
Mhm.
is very similar to computer science, but a bit more varied, I guess.
Mhm.
We didn't have that much, like we didn't have compiler
Mhm. Okay.
courses on compilers or interesting. Well, I wouldn't say interesting. Sophisticated searching algorithms that you have in computer science courses.
Mhm.
It was signal processing, cryptography, statistics, a lot of statistics actually.
Mhm.
And the
Mhm.
guy who invented, CDMA, the Vetterli algorithm, which is used in all the phones right now. CDMA, this amazing algorithm where you um, uh, discover you send a signal on a large bandwidth and you get it back through a statistical matrix.
Mhm.
It was invented by a guy called Vetterli. That's the guy who
Mhm.
gave the name, and he became the president of our school,
Uh, the,
of EPFL.
hey, your school was crazy, The Logitech was started there. They built their own computer. They created, algorithm for CDMA. This was like, this is better than Silicon Valley.
I'm not trying to sell the school. The
No,
school is doing
no,
quite
we
well.
should sell this school, because if there is something in the near, why to promote, far things? I mean, there's Lausanne in Switzerland is not far away, but I was not aware that there's a so high-tech school there, right? So.
It's quite highly ranked. I don't really follow, but it's, yeah.
But most important thing is it was fun for you, So if you enjoy learning, this is the most important thing.
Yes, that's true. It became very competitive. I have friends who have now adult children, and they say it has become an extremely competitive, bigger school, more competitive. So I don't know if they are enjoying the school that much, because competition has an effect on fun. It's less fun, right, if you have to compete. But yeah, it's definitely a good school, and I quite enjoyed it. I had a lot of luck, I must say.
Yeah, you say that, but what I assume, you also enjoy that. So if you enjoy something, you spend more time with it. You are learning more, and maybe it seems like luck, but actually it is hard work without noticing it.
Yes, that's implicit, but I think it was also a lot of luck.
Okay, so I don't know you actually, so this is just my observation, because so yeah, humble guy, but if you have to do something, nothing happens just out of nothing. So that's what I wanted to say. Yeah.
You have to push the luck a little bit. That's true.
Exactly. You also learned about routing, TCP/IP stack, the OSI layers, I think, right? This was the main.
Absolutely. And on that note, I had a semester, not a semester course, a course project. I think a practical project to do at school regarding TCP like protocols. Is it called congestion or connection protocols? I don't remember the name. There's an official name for that. So these transport protocols, right? Transport protocols. And TCP as a protocol, it's one of the simplest ones that you can imagine. So you can have a protocol imagined by someone who has no schooling at all, no interest in the subject. So it would be like a ping pong protocol. And then, like this, after perhaps 1 hour thinking about the problem, I think most people would invent TCP, because it's a very, very simple protocol. It's quite primitive, actually, as a protocol, and we're still using it 50 years later, and it has stayed at its core the same. And that was quite a marking experience on me, because I said, if you spend 2 hours, you can invent something more sophisticated, but a bit more hard to understand, and it would be harder to implement, right? So ease of implementation is a really interesting property.
Yes.
And SLF4J, we'll maybe talk about SLF4J, has this very hard position on its core implementation. It's like the stupidest thing that you can do in Java, and that's what SLF4J does. And I wonder if it has a link to its success. Maybe we can talk about it later.
You said, if you invest 2 hours more, you can make it more complex. So I have to say, I spent a considerable amount of time in my projects to make it simple. So you write something, then you look at this and say, okay, it can be simpler. So you try to use better names. You try to either if you have one method, add additional methods to make it simpler, or if you have too many methods, you say, okay, it doesn't look right, so you try. But it's just continuous refactoring without adding any functionality. So I would say I was actually in a bank, and the project as a freelancer, I always work as a freelancer, and the project manager as a consultant told me, since I'm there, they have hard time to justify the money they are spending because nothing happens. The consultants before me, they generated lots of code and did crazy things, and we write a few Java classes and it works, but the amount of classes we are producing is nothing comparing what happened before. And then I say, okay, we can generate something to make look it better. But I would say from the maintainability perspective, if you have a few things and they are simple and everyone understands, this is actually the thing we have to solve. And so I would say, create simple things takes time. And even if you think this way, you create the first one, then you go to sleep next day, you wake up and say, actually, there's a better way to do it, right? And you redo it, and then it takes time. This is my observation.
Of course, I mean, I think we are in full agreement, and of course, people asking you to produce more code or more classes, I think that's clearly the wrong incentive, right? So with wrong incentives, you can go very far. You can go into a rabbit hole, and you think you're doing the things correctly, but it's all counterproductive. And simplicity is generally a good incentive, because I assume you don't still work in the same bank. Somebody has replaced you. That person has to read your code, understand your code, and proposing having them have a simpler life, easier life is something very worthy. And in time, banking projects last sometimes for 2 or 3 decades, and simplicity is really it pays at the end.
But it's hard to sell, right? This is hard to sell to managers, because if they see how many classes you produced, and there are lots of classes, oh wow, yeah, you did something. But if if you produce, it really depends, because in other projects where you are actually judged by the features or on the overall experience, no one cares. This is more like in more bureaucratic projects where they start with the question, how we measure, how to create statistics from your project. Is okay, this is already beginning from the of the end, because they will measure some numbers and they will judge you by the numbers, and not actually, no one wants actually to spend time with the software. They just want to have a metric and say good or bad, and this is but
it reminds me of the talk you had on unit tests, that you said that some people wanted the absolutely 80% coverage, and or whatever percentage. And if the incentive is to have high unit test coverage, you can test silly things, but doesn't bring you added value.
Yes.
And it's an incentive gone wrong. You have to choose the right incentives for the project to succeed.
So you saw my talk?
I listened to several of your talks, and I enjoyed them quite a bit, I must say.
Oh, thank you. Because have we ever met at conference or somewhere?
It's possible. I used to go to ApacheCon in Las Vegas. I went twice, I believe. I went to Devox as a presenter long time ago, 2010.
Okay, then Devox. Okay.
Yeah.
Okay. You are right, but with the unit test, because I would say this is actually how this would be interesting. You said, you build the software with Turbo Pascal, right? And you enjoy that. I assume there were no unit tests, but I would say what I guess what you did is to minimize errors. You started, the software several hundred times a day and watched, does it work or doesn't? And this is from unit testing. And then you save it somewhere if it works, not to make mistakes. If you have, because it's okay, this is my tag or whatever, this is the released version. And if it doesn't work, almost like a branch, right? So if you really would like to build software, you do the agile way without knowing it, right? So, and you will write unit tests, you will do whatever necessary to make the software work. But if you are only interested in the job and you are not interested in building software, so you need a kind of guidance But this is already, you lose already, I would say, 50% of productivity because you're following rules without knowing why. So this is maybe, the passion, your passion is going away if you just, following your rules and you are not knowing why it happens or what is the reason for it, right?
Right.
So this is what gets lost.
I think there are so many ways of forcing software projects, go wrong. You can have, especially in highly tightly controlled environments like banks. I've worked at several banks as a contractor, and the degree of freedom that you're allowed, it really varies from bank to bank. And in some places, the degree of freedom you have is so small that you can't get anything accomplished. And at the end, independently of the goodwill that you have, you realize that you can't get anything done. And the only solution is to leave, even if you like your working environment, your colleagues, the salary, but it's the environment is so burdensome that it's hard to survive, and it kills the buzz of all the enjoyment that you can have in your work. And that's particularly in banks. I think there's a lot of variance, but banks are quite bad at this.
Yeah, and when the project gets larger or another company takes over, so the spirit gets lost. So this is the problem. But
sure.
Interesting discussion. But what we should go back, to your school with the network programming. Are you Cisco certified?
Absolutely not.
Oh, okay. I thought that is because if you studied the networking back then, this Cisco router certification was a big deal. I would say. I assumed you just did it because it's no big deal. You could do this. So and at the networking programming course, you still did. I assume C, right? You had to learn C in one point of time, not just Turbo Pascal.
One of the earliest languages I learned was C. We had a C programming course, and of course, I think it was the first hour or the second hour, we got introduced to pointers, and just my mind just went.
Yeah.
And I remember I had quite a hard time understanding pointers at the beginning, and I don't know how much time I spent, but it was, I think, several painful hours. And at one point, I got it, and once you really get it, it's okay. It's you go to a different level of understanding, and it was fine. I did the linked lists and all kind of stuff that you can only do with pointers, right? And so I did C++. I did a whole cryptographic stack on public key cryptography using C++. The RSA algorithm, implemented it from nothing. All the what is it called? Arithmetic, large number arithmetic. I built a library for that, and it was really, really fun. I remember the awe that I felt when implementing division, and the division algorithm. If you really think about it, there's kind of magic in it when you guess the quotients, and there's an algorithm for this presented or in Donald Knuth, the mathematician. And I still find the algorithm magical. It's very simple. Everybody knows how to do division, when you go to even at elementary school, and there's still something quite fantastic about it. So that was my C++ experience.
So you read also the book from Björn Strustrup, right? This is.
I think so. I honestly, I don't remember reading it.
And you enjoyed, in C++ the C in, C out, operator overloading and templates, or not?
Yeah, I think no. I think operator overloading is like it goes count. It's fun, right?
Fun, yeah.
Especially when you do arithmetic, large number arithmetic.
Yeah.
The plus is or the minus or the division is so natural,
Yeah.
right? But there is kind of the effort you spend. So operator overloading, you can only have a limited number, an argument on the left, an argument on the right.
Yeah.
You cannot have a third argument, for example, the memory buffer, right? So in practice, you can't do large number, arbitrarily large number arithmetic using operator overloading if you care about performance. So that's one point. And the thing is, it can really be overdone, and it gets confusing. It gets hard to understand. And one extreme example of that is the Perl language, where you have all these weird what is it called, like operators and things that have you have to really know the language to see what it does. And if you stop using it for 6 months and you come back, you can't read your own code. And that's also was a formative experience. I did this project called Babel, which was based on mixes. I don't know if you know what mixes are. Mixes are
mix in or mixes?
Mix. It's this machine which takes in emails. It was something invented by Chaum, a cryptographer. I think he's Belgian. I'm not sure. And so it takes messages from many parties, it mixes them, and it spits them out in a different order. And you can cascade them, so you can have multiple mixes, and that guarantees anonymity. And it has this wonderful property: if you have 3 mixes, you have to break all 3 to discover the people, the parties talking. Which is kind of an amazing property, right? Usually, it is enough to break one of the components to gain access. In mixes, you have to break all components to break the system. And so I did my last school project, master's degree project, was done at IBM Zurich. In the research lab, IBM's research lab in Zurich. And there I implemented a mix system where you could send an email, an anonymous email, and the person receiving the email could reply to it anonymously.
Wow.
And this was in 1995 or something, 96 or something like that. And I presented this with my thesis professor, thesis professor Jean Sudik in San Diego, and we met by chance a couple of guys from the American Navy, and they implemented Tor, the Tor system.
I wanted to mention that this sounds like Tor.
Yes. Yeah. So the name onion routing was invented where it was what is it called, put forth by Jean Sudik. He said, "Oh, this is like onions. Let's call it onion routing." Yeah. And so I'm quite proud of that. That Tor is kind of I can't say it was my baby, but like the invention that allowed talking back. That's my master's thesis project.
This is crazy. So so I mean, what you did, this is even better than some startup in Silicon Valley, I would say. There are lots of lucky accidents, as you tell me, but for me it's actually interesting. And as you started with the mixes of the emails, I will ask you about Tor, because it sounds similar to me. And
absolutely.
Yeah.
I mean, Tor is the so Chow invented this onion routing in one sense, in one direction, and the networking experience that I had. I said, okay, so this is like we can actually encapsulate the route in the return path in cryptographically, and include it in the outgoing message. And this is what old onion routing systems do, like Tor and so on.
What was the title of your thesis?
It was Babel mixing an anonymous connection or something like that. It's on my website.
Okay, so put show notes so for the listeners.
I'll send you a link.
Perfect. And you did it with Java already?
No, I did it in Perl.
Wow. We will cut it out, after all, after discussion before and after.
Yes,
okay.
Please do. Absolutely. Nobody should know.
I never did Perl. I wanted to learn it. I actually have even bought a book from O'Reilly. This with the camel, I think.
Yes.
Yeah. And I wanted to read it, but the problem is I started with C++ and Java, and then I got so many projects, so there was never time to learn Perl.
I don't think you have missed much. I mean, how can I say this? It was bad before, and it really got even worse today. With
we get lots of comments, I think.
I have no ill feelings.
No, it's great.
Feel people who love programming in Perl, please continue doing so. It's.
And send code to Jackie for review if they.
No, the thing is, you write code, you come back to it 6 months later, and you can't read it, and that's like it's a no-no, right?
What surprised me, your answer regarding operator overloading. So what surprised me is your maturity and pragmatism. I was different. So back then, if I learned C++, I just enjoyed, the C in and C out, just the data flow and the operators. And I remember I wanted to have an operator overloading for metrics, multiplication, for instance. And this was lots of effort, but it was fun because, spent for me 1 weekend or even more to overload the operator. And then one time I could call it, right? So this was why, and then was the enjoyment on my side. And but it was how to call it? It was not necessary, but I enjoy it. So this is why I wanted to learn more, and just like a magic, almost like a DSL, maybe. What I really like, I wanted to extend the language, because my thinking back then was, all the for loops or whatever is just boring. So if we just if we just replace them with characters, it gets more and more powerful. And this was my thinking. I was a student, but I really enjoyed C++, I have to admit. And then Java came out, and I was disappointed at the beginning. So this is why I'm curious to know what your road to Java is.
So I must admit, I also initially liked operator overloading, and I also remember thinking, oh, Java doesn't have operator overloading. What a primitive, stupid language. And the more you think about it, the more you realize that it's not that important. And DSLs, if you're not careful, they're a huge waste of time. I mean, the number of DSLs that you have to deal with, and in particular, I must admit that there's the LogBack DSL and the Log4j DSL, and that I'm responsible for. I apologize to all the parties that have been wounded by those DSLs. And I realized that, I mean, if you're not careful, you can go on a path which is wasteful, and it wastes other people's time. And one example is Scala. I don't know if you have programmed in Scala. In Scala, you can do a lot with the types. And it can go. I mean, you can go really crazy with the type stuff.
I can tell you my story to Scala. First, I wanted just to learn Scala because I assumed I do a lot of application servers and JMS and whatever, and as Scala the first mention of Scala was Martin Odersky at the JAX conference, I think. I have even talked with him.
Also from EPFL, by the way.
Oh, this is crazy. What this is, I have to visit the location there. This is like, this is like the mecca of software engineering.
Ugly buildings, I must say. There's nothing to see. It's not like these American universities where you have beautiful gardens. It's almost like a golf course. No, it's not like that. It's just really ugly buildings. They don't look like anything interesting. And then they're quite ugly, I must say.
Oh, okay, so still, at one time we have to, right? But and I chatted with Martin Odersky back then, and what I expected is that my Java E and JMS won't scale, and I will have to use Scala for that. And so, okay, if this is the case, I will learn a bit Scala to be prepared. If my ideas go south, so I have a plan B. So I started to write tests with Scala, and what was really terrible is the compiler performance. So I would say I was too impatient. Like, I cannot stand that. So I was okay. So, but regardless, it's going to be faster one day. And what I did then is I was curious. So I started to click, on the library classes in Scala. And I couldn't understand anything. So I took a look at the code, like, what's going on there? And I said, okay, I will ask, the Scala gurus at the next conference. So I came back to the conference and asked them, say, yeah, you are not supposed to read that. You are the application developer, not the library developer.
Oh, wow.
And I say, okay, yeah, but I mean, this is not how I'm working, because usually I would like, in Java, if I click on something, I understand it. So this is my way. If I'm too lazy, to look at Java doc and string, I click on the string and I see what's going on a little bit and read the Java doc, and this is my way of understanding Java.
Sure.
And back then, this was the official statement that Scala is perfect because they're like a library developers and application. This was not like, it was not like a bad answer. The answer was nice. This was back then, the idea how it is supposed to be. But I lost a little bit interest. And by the way, it happens a lot. We mentioned Perl. Then people ask me why I'm not using Jython. Then Groovy. Then Scala, of course, Clojure, and now Kotlin. And I have no time to to learn other languages because I had so much requests in Java. And whatever they asked me 5 years ago is no more JRuby, huge. Why I'm doing Java, Ruby on Rails, will win. And the funny story is Java is doing fine over the years. So this is what really surprised me. And at least in our area.
I think it's a very interesting point. But I must say that we're coming. I mean, from a kind of how can I call it? From a philosophical point of view. Mm-hmm. Is it's better to stick with things which are tried and true. Java is used by millions of people. They have, I must say, the stewardship by Sun and now Oracle. They're doing quite an amazing job evolving the language, and it's a very hard job, I think. But this doesn't mean that because the Scala experience wasn't so conclusive, the Groovy experience wasn't so conclusive. This doesn't mean that Kotlin will also fail, right? Or fail is a very strong term. Or Kotlin might be a huge success. I don't know Kotlin. I've seen a couple of talks about it, but I haven't tried it myself. But they seem to stick to a more pragmatic point of view or pragmatic philosophy, and it might be different,
Yeah, what I did, I performed lots of code reviews, and some were also Kotlin projects. Okay. And I took a look at the code, and I said, okay, it is a little bit nicer, but with Java 17, it's not that worse. From my perspective, if you would like to be better, you have to be better more than 10%. Otherwise, it's not worth. And another thing, what I also thinking, so Java is the lowest common denominator if you have JVM. Yes. No one will ask you why you're running Java if you have JVM. If you use something different in commercial project, I would say at least you have to answer the question why you are doing this, because there has to be a reason. So if you have JVM, why you're not running Java on that JVM? And in larger projects, so back then, Groovy, I like Groovy a lot. The problem is, if I in project would say, okay, let's do Groovy, guaranteed another person in the team will ask me why not Scala? It's type safe, and then you're opening the Pandora box, and everyone will discuss just languages, and we forget about the use cases.
Mhm.
So for me, stick with Java is actually the trick. We don't discuss that because we have the JVM. What I would do, this was my plan actually. If Java goes south, I will pick complete different stack without JVM, Ruby or Rust to do, or Swift to do completely different. Why I should patch Java? I mean, we have already Java, and if it's good enough, maybe Kotlin. I think Kotlin is very popular because also of Android, right? So this is if I would
Right.
go to Android, I will use Kotlin, because this is the language for Android. So, and if I would do Apple, I would try to pick Swift first. And Rust is an interesting language as well. So I would say, if I would not satisfy anymore with Java, I would try to pick something which doesn't run on JVM anymore, because even if you use Maven, for instance, always you have the Java dependency, then you have the Kotlin language dependency in Maven, and I have to say, I'm really fine with Java 17, and if looking what's coming, Java 1920 with Loom and all what the Oracle people are doing, and the destructuring with Java record classes, this is amazing. If this come out, it's almost like a JavaScript which is type safe, without any external dependency. This is what I like. I have just one Java doc, one language. I don't care about anything else, and then I'm productive. Because not only I'm productive in project, I say, look, we just use Java. This is the Java doc. This is the way to do it. And what really developers are still amazed how much you can achieve with Java without any external dependencies. For instance, today I perform a code review. They used IO.utils toString, which is a strange name, but what toString does, it expects an input stream and converts an input string to string, right?
Okay.
And I say, okay, but what do you have? Files, read string, ships with Java. So we don't need the Jakarta Commons, IO.utils.
Right.
You can use from Java the same. Say, oh yeah, we didn't know that. So you say, the only thing is, before you look at external dependencies, take a look at Java, because we have things, and the cool story is Java moves slowly. So if you learn Java, you have more vacations. You don't have to chase external things, right? So this was my thinking, but I don't like. I like Kotlin actually. They're great ideas, but I would use Kotlin in my leisure projects, and in a larger project, I try to be cautious. What are the rules in the project? I just try to stick with the standard. So this is.
I agree completely. That's a very strong argument. Sticking with the standards, sticking with what is tried and true. And I remember, and to counter argument, I remember a friend of mine in 2003 or 4 said, I was working already on Log4j version 1, and he said, look, Sun just came out with java.util.logging in JDK 1.4. And he said, look, your project is doomed. There's no future in Log4j. And I said, well, yeah, maybe, who knows? Maybe you're right. But and of course, there's Log4j has a very long history. It gave birth to SLF4j, then to LogBack, and then Log4j version 2. And I don't know if you're aware of this. SLF4j is the most deployed artifact in the Java ecosystem today.
They knew that.
You knew that?
No.
You didn't. Okay. The number of downloads on Maven Central, it's like the numbers are absolutely crazy.
And not Jakarta Commons lang, or not for is blank. The string is blank is not blank. Is like still the hit.
Okay, maybe the Jakarta Commons because in Jakarta Commons you have like 30 projects, right? I'm talking about SLF4j API as a single artifact. Maybe it's not the most widely deployed. Maybe it's the second. What I'm trying to say is it's quite
Popular. Yeah, this is what I imagine. Yeah,
it's a
it's
very
everywhere.
popular.
SL4J is everywhere. And I also use it a lot with Payara and Glassfish because this is the way to separate the Glassfish logs from application logs. So,
All right. Okay.
yeah, this is what I also used. But I would say we should cover Log4j and SL4j completely in another episode.
Oh,
and what because and what I would like to know today, is the Tor. This is actually that we have, a complete cycle. You wrote to Java, and then I can also tell you something with Log4j and how I met you virtually years ago. So, you said with the Tor, right? This was your thesis, and you did it with Perl. What happens afterwards?
Interesting. What happened? So this was at IBM, right? I did my master's thesis. The semester project you could do either at school, or if you could find a company, an enterprise willing to take you in, you could do it in a company. And that's what I did, because one of my professors was an alumni of this research lab, and he recommended me. And so I went to Zurich for 6 months. And actually, the reason I went, one of the reasons was that the salary as a student was quite high. It was like 3,500 francs. It was like, wow, I'm going to be a rich. I'm going to study and then be rich. So I think I'm not 100% sure that that was the reason, but it was quite pleasant to have a salary and work at the same time on something that you actually enjoy. And at the end, I made a demo of this project, and the IBM people were quite hesitant, because anonymity, which is actually really strong anonymity, which even governments cannot crack. I mean, you have to be, you can control all the telecoms in your country, but if the packet leaves your country, goes somewhere else, even if it comes back, you still not crack you can still not trace the source or the destination. That's something that my suspicion is that it scared people at IBM. I mean, nobody told me of point blank, oh, we are scared of this project, where it might lead. It wasn't like that, but that was my feeling, that they were wary about this technology, and it's easily understandable. If you have really strong anonymity, it allows for criminal enterprises. You can do what is it called? Blackmailing, all sorts of evil things. But you can also use it for good. Of course, if you're living in a tyrannical society, a police state, it's a way to communicate with the outside without being traced. Well, that's the theory, because in reality, for example, Tor, the entry and exit points, they're not so many. They're just a few thousand. I don't know if it's like 3,000 or 10,000, but it's a limited list. And if there's a government with very strong surveillance powers, they can still see who, if you're talking to a Tor node, and they can say, what are you doing using Tor? And they can knock on your door and do bad things to you. So anonymity does not guarantee that your society will be free in a police state, but in a free society, it makes it harder to become a police state. I don't see if you see the difference. For example, in a free country, a lot of laws that are restricting, for example, in Switzerland, we have this law where you cannot use casino sites which are not authorized by the government, right?
Mhm.
and there's all the telecoms. I believe maybe I'm not 100% precise about what I'm saying, but the telecoms in Switzerland they have to obey the law, and
Mhm.
so if you go you connect to a casino which is not authorized by government and does not pay taxes,
Mhm.
they can block you. But
Mhm.
of course, you can circumvent that quite easily with using
Mhm.
Tor or VPN or whatever.
Mhm.
Because Switzerland is not a police state, but one day the government could say you are not allowed to use VPN, and we know all the VPNs in the world.
Mhm.
We know all the entry points for Tor, and yeah, it's game over. So
Mhm.
there's always um, this tension between freedom and the state, and Tor is quite an interesting incarnation of that.
Yeah, I can imagine what IBM thought, right? Because if it's really that private, then they will have, by law in US, maybe, know to provide a backdoor something. And if you provide a backdoor in a private communication, it's no more private. So it is really hard, to have a backdoor for someone and keep, the private for everyone else. What I also remember, there was from Cisco a flow management solution who was able to how to call it, to make Tor less private. It was a couple of years ago, so they were able to track the packets. So maybe you do the research, and the next time we can talk about this, may be interesting to you. I just remember, like, I think it was from Cisco software, and something was no flow analysis of the Tor packets,
Sure,
and
sure, sure.
they were able now to track to track them
Yes,
back a little bit.
statistically, you can do
Yeah,
statistical.
yeah,
Of
exactly.
course, of course.
Yeah, exactly.
That's my thesis actually.
Ah, okay.
Yeah, I tried to do that. So I put in place the system. Then I said, oh, so
Okay.
but what's the next step? And of course, it's traffic analysis,
Yeah, traffic.
and
Exactly.
I tried to put in place a model. And since I'm not that good in math, I'm okay, but I'm not really brilliant. It kind of I broke my teeth trying to modelize that, and it didn't go anywhere. But
Hmm.
one thing that I can say is all these like Tor, the it's very they are very vulnerable to nodes which pretend to participate, but who are actually in a denial of participate in a denial of service attack.
Hmm.
So it's very easy. You can, as a Tor node, you just drop packets,
Hmm.
and it's hard to track,
Hmm.
right? Because everything is anonymous and
Yeah.
untraceable. But you can disrupt communication for all the nodes all the communication that go through your node
Hmm.
as an attacker, as a
Hmm.
denial of service attacker, and that's quite a hard problem. And Tor, they have these honeypots, I believe.
Hmm.
They test the circuit, and if the circuit breaks, they go to a different alternate route, and they can isolate nodes which are basically which pertain to an
Hmm.
attacker.
So what did it tell you? The health check. I said there should be like a health check. So you
Yeah, yeah,
ask,
yeah,
the
of course.
node or something like, or synthetic transaction. You go to the node and say, okay, give me back, and if you get the response, you're fine, right?
You're right.
Cool.
Yes.
And okay, so then was it semi-successful? What happened with your thesis or nothing? And then
Nothing. Nothing
okay,
happened.
okay.
Nothing. So it was just shelved. And this is a problem in all these research labs, right? You have really brilliant people. I must say the people I work with, I've rarely met people of the same caliber. Uh, well, I've met people of great caliber, but the concentration there was quite amazing. And I should say, the Log4j, the algorithm to um, um, to propagate levels in
Hmm.
a tree, in a name tree, that wasn't my idea. It's an idea we came up with colleagues, three colleagues who
Hmm.
were doing their PhD. We got together and we thought about this problem for maybe an hour, and and we came up with this idea. And I don't think it was me who came with the idea. It was a colleague called Michael Steiner, I believe,
Okay.
who came up with this. And it was like, once it's stated and you understand it, it's like, wow, this is the way to go. And it took the world by storm, right? Everybody today uses the same system.
What is from Perl to Java? What happened that you started to do Java? Was it something in between?
No, it was basically IBM decided that they would adopt Java as a programming language in their projects. It was highly encouraged. And basically, I never had the choice. They said, "Oh, Java, look, this is the language we are using now." And I looked at it; it was fine. I liked it, except the operating overloading, of course, which was missing. I was like, wow.
What I didn't like as well I didn't like the interfaces. I preferred the C++ include header files. So there's for me it was cleaner than interface in Java. In C++ there was the H header which you had to include.
Yes, of course.
And in Java the interface. And I say, okay, the header is somehow I forgot what was the reason. I really preferred the header at the beginning, and now of course it's fine.
But you have macros in C and C++.
Yes.
Right. And some people macros give you a lot of power. I remember missing the power of macros, and today.
No, not only macros, generics.
Oh, yes.
So, yeah, in C++, I remember the generics were Turing complete. This was our own language, right? So you could actually, this is what I missed. Macros I did a bit, but I couldn't understand them, I think, back then. But generics, I was actually really into generics because you could do more than Java with the C++ generics.
Of course.
And the header files. I really like the header files because, why I like them? Because they were linked and they were separate, but Java interfaces are also separate. I don't know. But this is the operator overloading. Generics were not at all in Java. It was too early. Back then I started with JDK 1.0. And what was your first project with Java? You remember this?
I think it was Log4j.
And you started it because, so why you started this?
Because we had this European funded research project called Semper. And we were trying to implement a secure device for signing transactions.
Okay. And this was for IBM, right?
This was for IBM and a bunch of other companies which were connected to the project, but mainly IBM, yes. There were universities, several universities doing cryptography. And at one point, it was a Java project, and we said, "Oh, there's no logging library in Java, so let's write one." And so we came together, and Michael Steiner said, "Oh, how about this tree of loggers that inherit a level, and you can do filtering?" And it was such a great idea. I implemented it. It was incorporated into the project, and everybody loved it immediately. I got lots of congratulations. This is really great. The rest of the project doesn't work so well, but the logging is just fantastic. Logging is fantastic. And I said, "Oh, okay, there's something, people like this. This is valuable." Yeah.
Okay, so I think we should stop here. So just a cliffhanger.
Sure.
How I met you virtually. I think in one point of time you published a PDF book as a business.
Yes.
And I bought this book, and I really appreciated that you can have a startup, to sell PDF books. And I really wanted to use the Log4j in my projects, but this is a different story. But this is actually how I remember your name. And you were on java.net back then, and you say, "Okay, this is my business. I'm selling the documentation," as I remember. I said, "Okay, then I buy it," and I bought the book, and I was amazed that actually someone can sell books. This was a long time before, so I don't know. It was maybe 2002, 3, I assume, right? Something like this.
4 or 5, yes.
Yeah, something like this. Okay, this is how we met.
Right.
How we had a business relation already.
Right.
Where people can find, QoS.ch is your company, right?
Yes, that's correct.
And on Twitter or somewhere? Where?
At CEKI, Twitter, and My email is ceki@qos.ch.
Cool, perfect. It was really, I really appreciate the conversation. Lots of fun to me. So, and we never met, but it was nice, to
No,
the old days.
very nice talking to you as well. It was fun. Yes, absolutely.